Good morning, all of you. My name is Sabir Khan, and we will discuss about the strength of material. And today's topic is strain. So, basically, what is a strain? So, a strain, when we applied any force on a body, then the dimension of the body will somehow change. So, it is the ratio of the change in length or dimension, change in length or dimension to the original length or dimension. So, if I have I have a block. If I apply any external force to this block, then the nature of this force is tensile, so it will increase the dimension of this structure. It will stretch the block and uh, slightly increase the length of the block. So the strain is called as the change in length delta L, this change in length to the original length. It is the ratio of the change in length to the original length. If talking about the compressive stress, if I applied the low compressive force, then the length of the block will reduced. Reduced. Let's assume the length of the block slightly reduced. So that is compressive strain, and that is delta L to the uh, change in length to the original. So it is called the compressive strain. Uh, it is not only uh, on the dimension, on the length, that is on change in the volume to the original volume. That is also a strain. Change of width to the original width. That is also a strain. Okay, so now I'm talking about second part, that is shear strain. So what is shear strain? That if on this block I applied any force uh, on this structure parallel to the surface. Okay, so uh, one second. If we apply any load on this surface, this kind of, then what will happen? This length, this side will increase, this side will slide. Okay, so there is a change in angle due to this surface force or tangential force. There is a change in angle. So shear strain is what is change in this to the change of this length. Okay, so delta B by L. Okay, so it become 10 phi. 10 phi, and phi is small uh, because changes are so small. You can not recognize that change in naked eyes. So that 10 phi is just equal to phi, and phi become delta B by L. So if I'm talking about shear strain is the change in angle. Change in angle is called the shear strain. Okay, exactly, that is also change in length. Change in length, because change will happen in this side and to the original length. Okay, so that is also change in length to the original length, but the change that become 10 phi, and 10 phi is just equal to phi. So shear strain is shown by phi angle, change in angle. Okay, next, Hooke's law. What is Hooke's law? If I applied any external force to the body, then the internal resistive force or internal stresses will be developed, and that stress developed in the body, that is directly proportional to the strain of the body. As I increase the external force, there is some change in the dimension. Okay, so that as I increase the stressor, the strain will automatically increase. So stress and strain are directly proportional. That is called Hooke's law. And when that proportionality sign is removed, then the stress is equal to some constant times of strain, and that constant E is represented by that is ratio, that is stress divided by the strain, and E is generally called as a modulus of elasticity. Now, the unit of the strain, that is strain is unitless. So the unit of modulus of elasticity E is unit of stress. That means megapascal. So E unit of E is megapascal. In strength of material, we have three kind of modulus of elasticity. Three kind of modulus. First is modulus of elasticity or Young modulus of elasticity. So what is the modulus of elasticity or Young modulus of elasticity? If I applied any force linearly, that means compressive or tensile or perpendicular to the surface, then the ratio of the linear stress to the linear strain. Strain is delta L over I, and stress is that force per unit cross sectional area. So that is modulus of elasticity. So if we applied uh, external force normal to the surface, then the linear stress to the linear strain is called as the Young's modulus of elasticity or modulus of elasticity generally. But if we applied the force, external force, to the tangential to the surface, tangential to the surface, then then there is a shear stress developed as well as shear strain developed. There is change in angle. So if I applied any force or any shear force on the body, then the ratio of that shear stress to the shear strain is called the modulus of rigidity. And in third case, if I'm talking about the bulk modulus, what is bulk modulus? It is like if I applied any stress to the body, like a balloon pressure or a constant pressure or a constant stress on all element of the body. If we applied a constant pressure or a constant stress in all direction in a body, then the volume of the body will change. Okay, then the volume of the body will be changed. So that stress to the volumetric strain. What is volumetric strain? That is a change in volume to the original volume. So the stress to the volumetric strain, the ratio of stress to the volumetric strain is called the bulk modulus. So we have three modulus. Young modulus of elasticity, that is the ratio of the linear stress to the linear strain. Second, modulus of rigidity, that is the shear stress to the shear strain. And third and last one, that is the bulk modulus, that is pressure or stress applied to the uh, body, and the ratio of the stress, that is stress due to the volumetric strain, that is called the bulk modulus. So in strain, one more things are there, that if I applied any force in its longitudinal direction, like if I I have a rectangular block. If I apply any force to this longitudinal direction, then the length of the block will be increased by delta L amount. Okay, by delta L amount. But at the similar time, the width of the block will decrease. If I apply tensile force, then the length of the block will be increased, but the width of the block will decrease. So the change in width to the original width is called the lateral strain. It is change in width. If I applied the load in longitudinal direction, then the change in width to the original width is called as a lateral strain. Understood? So there is a lateral strain, and the lateral strain. What is lateral strain? Lateral strain, the change in width to the original width. If the width of the block is b, then one second, change in width to the original width is called lateral strain. The lateral strain is change in width, but the force is in the direction of length. Change in width to original width is called the lateral strain. But that is not a change in width to the original width. Only when the load is in the direction of length, then this lateral strain. And these compressive and tensile strain is called the longitudinal strain. Change in length to the original length. If I applied any force in the direction of length, then change in length to the original length is called the longitudinal strain. And the type of force, the nature of force, that is tensile or compressive. So, on the basis of the type of force, we will decide that this is tensile strain or compressive strain. But both are longitudinal strain. Okay, both are longitudinal strain. One more thing, what I need to tell you, that Poisson's ratio. And what is Poisson's ratio? Poisson's ratio is, it is the ratio of the longitudinal strain to the, sorry, it is the ratio of the lateral strain to the longitudinal strain. So you have to remember, it is the ratio of the lateral strain to the longitudinal strain. Okay, so the Poisson's ratio is the, it is the ratio of the lateral strain to the longitudinal strain, and the basically it is around point 0.2, zero point 0.3. Okay, so it's, thank you.